Good evening everybody. I welcome you all to this another edition of Clad exam preparation. In the last class we were doing exam 6 and we were on to question number 38. So I quickly move on to question 38 and then we start our next questions discussion. So this is question 38. In the figure below, the value at item G during the fourth iteration is. So G is a non-auto index tunnel, last value tunnel. So 2 is wired to it as the input and this value goes to the add and then gets added to the iteration and displays it in the H. The result is displayed in H. So irrespective of whatever the iteration is, this value will always be 2. So the value at G will always be 2. So the correct answer for this is B, 2. Let's check the results. This is question 38. Question 38 answer is B. So B, 2 is correct. Question 39. Which of the following could have produced this waveform? So this is waveform chart and we have to notice that what are the data values. The values are plotted from 0 to 5 range and the values are plotted at an intervals of 1, 2, 3, 4, 5 and 6. That means after one interval, 1 as the interval, data value is being plotted. So from 0 to 5 there are 6 data values and the first value is at 0, so the remaining values are 5. So it means that the interval between each value is 1. So this is our first observation about this chart. Then next, the first observation was that the values are plotted from 0 to 5, so the range is 0 to 5, and the second observation is that the intervals of plotting is 1. So let's see it in the, also observe one more thing, that the values plotted are integer numbers, integers. So the values over here 3, 1, 5, 1, 4, 2 and so on, all these are integers. None of them is a floating point value. So this is another observation about this chart. So let's see what type of code would have generated this. So first thing we have to keep in mind that the values are in integers. So this one is generating floating point values, so this could not be the code, so A is not the option. Then B can be an option, the values are rounded off to the nearest integer, so this will produce integer values, so this could be the option. So in C also there is no round to nearest integer, so the values over here are also in the floating point range. These are double values, so this could not also be the case. Then in D again round to nearest integer is chosen, so D can be the case. Now we are left with B and D. So in B you can see that 10 is multiplied by the random number. So values of random numbers range from 0 to 1, and if 10 is multiplied to 0 to 1 values, the values would be ranging from 0 to 10. So this will be out of the range because in the waveform chart the values are from 0 to 5. So over here this choice is also not correct, B is also not correct. So in D option we have the value 5 and the range is okay, moreover the values are rounded to the nearest integer. So D seems to be the correct option. So this waveform graph is generated by the D option. So let's check the answers. For 39 the answer is D, so we have also analyzed to be correct as D. D is the option. Next question, for best performance when programming a sequence of functions or calculations, you should use a sequence of functions or calculations. So we have only three options over here: stacked sequence structure, flat sequence structure. Both have both A and B have the same performance. Sequence of functions and calculations. So when we are performing sequence of functions and calculations, we might be running some variables from one frame to the another, and we will have clear cut idea of these functions and calculations if we use a flat sequence structure, because in the stack sequence structure we have to use a sequence local, and we also don't see all the frames at the same time, right? So we have to browse through the various frames. So it is much easier and to see the things if we use the flat sequence structure. And performance wise, I don't think there will be much difference, but for programming of course flat sequence would be much better. So the performance of A and B should be same, but let's see the answers. So question 40, the answer is C. The C says both A and B have the same performance. So that is correct, but for ease of programming we should use the flat sequence structure. Performance wise both A and B have the same performance. So that finishes our exam number 6. Let's now move on to the next exam. So exam 7. So we are going to cover, many questions are repeated in the exams. So let's figure out which questions to be done in this practice session. We are going to do this question number 2. What is the value in feedback answer after third iteration of the loop below? So this is very tricky question. So one is the input over here in the feedback node, which is taken one loop out, and one is given to the multiply button, multiply function, and 2 multiplied by 1 gives 2. Then again 2 is fed back, 2 multiplied by 2 gives 4, fed back, 2 multiplied by 4 gives 8, fed back, 8 multiplied by how many iterations? 4 iterations of 5. We have to find the answer in the third iteration. So 2 multiplied by 0, 2 multiplied by 1 will give 2, 2 multiplied by 2 will give 4, and 4 multiplied by 2 will give 8. So we have only 3 iterations to see. The remaining iterations we are not taking into consideration. So after the third iteration, the value over here feedback in the feedback answer would be 8. So let's see the results for question 2. Question 2 result is B. So it is 8. So this is correct. Question 8. which of the following could have produced this waveform chart? This question recently we have done. Let's skip this question. Question 15. Which of the following statements is true regarding the code in the loop shown below? The loop will not execute and the iteration I will return a null value. So let's see what is happening in the loop first. This is a continue if true conditioned while loop, and there is 150-second delay, 150 milliseconds delay. Then there is increment button and there is the iteration terminal wired outside of the loop. So what will happen if and the conditional terminal is wired true outside of the loop. So what will happen when such a loop such a code is executed? So the first option, the loop will not execute and the iteration terminal will return a null value. So this is not correct. The loop will execute because it is continue if true. So once true constant is when the loop executes, the true constant value is taken in the loop inside and it will be true, so it will execute. So this is not the correct option. The loop will not execute. This is not correct. The next option, the loop will execute once and the iteration terminal will output a value of 2. So this is also not correct because the value over here is always true. So loop will keep on iterating and there is no stop button to stop the loop, right? So this is also not true that loop will execute only once. No, the loop will execute once and the iteration terminal I will output a value of 1. This is also not correct. The loop will execute more than 1. The last option, the loop will execute infinitely and the program will have to be aborted. So this option is correct. Why it is correct? Because once this true value is taken inside the loop, then there is nothing to stop this loop. This loop is continue if true. So this while loop wired to continue if true condition, right? So this will keep on executing infinitely. There is nothing to stop the loop and the loop has to be stopped by pressing the abort button on the front panel or the block diagram file menus. So let's check the answers. For question 15, answer should be D. Question 15 answer is D. So this is correct. Next question to be covered is 18. If a required terminal of a sub VI is not wired in the block diagram, then so sub VI having a required terminal is not wired in the block diagram. The VI will generate a warning when executed. The VI will have a broken run arrow and will not execute. The VI will run without any dialog boxes, none of the above. So when you are not wiring a required terminal of a sub VI or any VI, so then the run button will be shown as a broken run button and the program will not execute. So this is the correct option. Let's check the answers. For question 18, answer is B. So question 18 answer is B. Next question to be covered is question 20. Under which of the following settings would you not apply a gain to your signal? So we are going to measure voltage signal and input signal is of 10 volt range with a 0 to 5 volt ADC range. So in this case the signal to be applied is 10 volt and the ADC range is 0 to 5 volt. So in this case we have to attenuate the signal. So this is not the application of gain, but needs to apply attenuation. 5 volt range with a 0 to 10 volt ADC range. This is already much higher than this 5 volt signal, so no need to apply gain for this. So 10 volt signal with a 10 volt ADC range. So this would be requiring not apply a gain to a signal. The previous one 5 volt signal 10 volt ADC can be used to apply gain over there, and already 5 volt signal when measured in the 0 to 10 volt ADC range, we will have many options to apply the gain. So here the gain would be possible and can be used if needed, and 10 volt signal with a 10 volt range. So there is no possibility of applying the gain to this 10 volt signal with 10 volt range, because the ADC range and the 10 volt range of the signal, they are the same. So there is no possibility of applying the gain. 1 volt signal with a 0 to 10 volt ADC range, there is a much possibility of application of a gain on this range. So correct answer seems to be C, 20 C. So the correct answer is C. Next question is 20, and then next question is 22. Which of the graphs matches the result in the register values after the following code has executed? So these are the shift registers and the values are being fed to the auto index tunnel and which are going out to the graph. This is the registers values graph, and we have to find out that which of the following graph matches the register values after the following code has executed. So what will be the values? Let's first figure out from the program itself. So as the loop iterates 5 times, so the first value over here will go and get stored at the auto index tunnel. Then the second value, first value will be 2, then the next value is 0, so 0 would be stored over here, and then the next value would be 4 and 4 would be stored over here. In the meantime, all the values over here will be fed back over here, so 2 0 would be fed back over here. So that completes the 5 iterations. So we will have values 2 0 4 and again 2 0. So these are the values which are the values to be plotted on the graph. Also they will be plotted from 0 to 4. So let's see the graphs. 22. So we have values 2 0 4 and 2 0. So 2 0 4 2 0. So this is the correct values plotted, but the increments are with 2. So this is not the correct way of plotting the values over here. So this is not correct, A is not correct. 2 0 4 2 0. So this seems to be correct, but the values are starting from 1 over here, x on the x axis, 1 2 3 4 5. So it should start from 0 1 2 3 and 4. So this also not seems correct. Then this graph 3. So this is 3 is not the value which we have calculated above. This is 2 0 4 and 2 0. And last 2 0 4 2 0, values plotted from 0 with an increment of 1. So this option D is correct option. So this is question 22. Let's see the results. For question 22, the correct answer is D. So last D option is correct. Next question 25. What is the value in Boolean after the following code has executed? So we have to see what is the value over here in Boolean after execution of this code. So this is the for loop and this is a shift register. Shift register is initialized with the value 5 and the for loop is having the loop count as 5. So 5 is what is transferred to the add, and every time the loop iterates, the iteration value is added to this particular value from here, from the shift register. Those values are applied back to the feedback shift register and fed back again over here, and then again the addition is continued. So we have to find out that after the full execution of this loop, means this loop executed 5 times, what will be the last value, and it will be compared with 15. If the value is greater than 15, then the Boolean will give us as the true value, but otherwise it will give as the false value. So 0 and 1 are not the values. The result could be between A and B. So let's do the maths for this. So 5 with the iteration as 0, the result is 5 plus 0 is 5 fed back. Then 5 with the iteration 1, result is 6 and fed back. 6 with the iteration 2 gives 8, 8 is fed back. 8 with the iteration 3 will give 11 and fed back. 11 with the iteration 4 will give 15 and fed back. So 15 over here is not greater than 15. It is equal to 15 but not greater than 15. So the result over here is false. So Boolean will give the false result. Let's see the maths for this. The maths for this is like this: 0 plus 5 gives 5, first iteration. Then 1 plus 5 is equal to 6, the second iteration. Iteration value is 1. Third iteration, 2 plus 6 is equal to 8, and this value is fed back. And then fourth iteration, the value of iteration terminal is 3. 3 plus 8 gives 11, fed back, and 11 plus 4 gives 15, and this is the last value. So this is actually iteration terminal values. So it means that if the iteration terminal value is 0, so iteration will be 1, means first iteration. For first iteration, the value of iteration terminal would be 0. So all applies to the same thing applies to all of these values. So we are getting the answer as false. So let's see the results. This is question 25. For question 25, the result is A. So the result is A, which is correct. Next question 37. Which of the following performs the most efficient conversion of random numbers of double precision into an array of single precision values? So we all know that random numbers produce double values, and we are going to transfer those values to single precision, and those values are to be stored in the arrays also. So which of the following gives the most efficient conversion of random numbers of double precision into single precision. So in this, as soon as the value from random number generator is generated, that is converted to single precision, and those are indexed at the auto index tunnel and then given to the array. So this is the first case, A case. Then over here 0 as a constant of single precision is taken. Here it is the double precision values of arrays and the output array. Again this will be of higher precision, means it will be of double precision, not a single precision. So B option is not correct. It does not convert the values to single precision. On the other hand, their values would be of double precision. In the C case, random number is generated of double precision, indexed over here, and the output array is then converted to single precision float. Now these values are stored in the array. So I think that this option A is a better way to perform this function of conversion from double to the single precision and then collecting them in the array using the auto indexed option. It is much better than this option. So let's see the results. According to me, the answer should be A, 37. The answer is A. Next question, 40th. How does changing a DAC board from 0 to 10 volt range to -2 plus 10 volt range affect the minimum voltage change that can be detected? So there is a DAC board with a 0 to 10 volt range, and that has to be that is converted to -10 to 10 volt range, and we have to find out how does it affect the minimum voltage change that can be detected. So you are converting the range from 0 to 10 volt to -10 to 10 volt range. So you see the span over here is 10 volt, but the span over here is 20 volt. So if the range is converted to double the range, means the span is converted to double the span, so the minimum voltage would also be minimum detectable voltage would also be doubled. So the correct answer for this should be that the voltage, minimum detected voltage, should be doubled. So the first option, the minimum voltage change that can be detected will depend inversely with the resolution of the board. This is nothing to do with the resolution, so this option is not correct. There will be no effect on the minimum voltage change that can be detected. This is also not correct. The minimum voltage change that can be detected will split in half, so this is also not correct. The minimum voltage change that can be detected will be doubled, so this option is correct. Let's see the results. Question 40, the option D is correct. That means the minimum voltage change that can be detected will be doubled. So that finishes our exam number 7. Let's now switch on to the exam 8. So this is exam 8, and let's see the questions to be covered. So first question we are going to cover is question 8. Which VI architecture allows the user to run several tasks concurrently? So we are going to run several tasks concurrently. That requires that there should be parallel loops running. So the correct architecture for this type of task to be performed in parallel is the parallel loop VI architecture. Next question. Next question is question 8. Question 10. The stop button shown below is an example of which data type? So this is clearly a Boolean data type. We have used stop button many times, and this is available over here. Stop button, and this is a Boolean data type, true false data type in the help shown. Next question is question 14. What is the result in output array after the following code has executed? So this is the code which is having index array function, and then a build array function is there. So in the index array function we have chosen the value to be 2, that means the third value would be chosen. So 0, 1, 2, that means 6 would be chosen, and that is available at this particular point. 6 is available here. So 6 is put into the input of build array, and 791 is appended to that. So we will have 6791 as the output array. This is option C over here, C option. So I have made this program. Let's see if the results are correct. So 24635, 791 and 2 as the index, 791 and 2 as the index. So these are the values. Let's run this program and let's see what is the output array over here. This is the element. So I have already explained that 2 will be chosen over here. So when I run this program, 6 is the element chosen over here, and output is 6791. So the correct answer is C, 1D array of 6791. Next question 28. No, next question is 22. Which of the following will allow you to run text-based code in LabVIEW? So we know that formula code is used to write text-based programs in LabVIEW. So correct answer is B. Next question is question 25. The question 25 says, what is the value in length after the following code has executed? So we have to find out how many characters are there in this particular string, and we are using the string length function. String length function returns the number of characters in a particular string, and as you know, all the characters in a string are actually the ASCII are having the ASCII values. So we have to count even the space and the underscores as well as the special symbols such as the exclamation mark, question mark, comma, tab and everything else. So all of these are ASCII characters. So over here underscore is used and exclamation mark is also used. So we have to count the number of characters over here. So hello is 5 characters, then underscore is 6, then world is 5 again, 6 plus 5 is 11, and then exclamation mark will give 1 as 12. So total number of characters would be 12. So the correct answer for this is B, which is 12. So next question to be covered is 28. Which of the following will continuously display multiple plots on the same waveform chart until stop button is pressed? So there are many options given here to plot 3 random number generators onto the same waveform chart, and 3 of them are showing different waveform on the waveform chart, means all of 3 will have different colors plotted on the waveform chart. So firstly we have to see that which logical programming is correct. So if we are going to display the waveform chart, we must have to include the waveform chart inside the loop. So this option over here, which is having the waveform chart out of the loop, will not be displaying the random numbers which are generated, and so this option is not correct. Again, option B is having the same problem. It is having the waveform chart out of the loop. So again, this will not be displaying the random numbers while the loop is running. And in option C, we have the waveform chart inside, that's fine. In option D, we also have the waveform chart inside. So we must have to choose between option C and D. Now in the option C, we are using the build array function. So build array function will actually concatenate the random numbers and plot it as a single waveform. So this option will not plot multiple waveforms of different colors, it will plot a single waveform of the concatenation of these build array functions into a single waveform. So this option is not correct. The last option remaining is bundle function. So this will bundle the elements together and then plot it as a different waveforms. So I have made a program regarding this question. This is question 28. So let me open up this program. So this is the bundle array function, 3 random number generators bundled together and plotting on the waveform chart. I have given it 200 millisecond display so that the plots are visible properly and they don't run so fast that we are not able to distinguish. So I am running this now. So see, 3 different colors of waveforms are there and they represent different random numbers generated in the loop and they are bundled together. So this option over here, D option, seems to be correct. Now I will plot the same graph using the arrays. So you will see the difference when I am choosing the bundle function to be replaced by arrays. So what is happening? I am replacing it with the build array, and now you see there will be no multicolored waveforms because they will all be appended together in the same array, concatenated. So see, there is only one waveform, so which clearly shows that there is concatenation and only one waveform is generated using the build array function. So the correct answer is D. Next question. This is question 28 and now we are moving on to question 30. 30 says, if a user needs to enter a name on the front panel and then use the name later in the VI, they would use a, so the best option for this is a string control. Next question. Next question is 34. Which DAC board will allow for the detection of 2.1 millivolts change in signal if a 0 to 10 volt range was selected? So this one is a very interesting question. So we have to detect a signal of 2.1 millivolt and the range is 0 to 10 volt, and we have to see which resolution of the board is supported to have this much change in millivolt signal and detection of that signal using that resolution. So how to proceed in this question? We have to do some math over here. So let me open up the math. So for 12-bit board, 2 raised power 12 is 4096. That means these are the discrete levels available for that resolution, and we have to divide the 10 volt range with the number of resolution levels available, discrete levels of the resolution. So 10 divided by 4096 will give 2.441 millivolt. So this will be the minimum detectable input voltage change if the resolution chosen is 12. So then 12-bit board will not be able to detect this 2.1 millivolt, because the detection over here is 2.44 millivolt, which is greater than 2.1 millivolt. Then the next is 16-bit board. For 16-bit board, we have 2 raised power 16 as 65536 as the resolution levels. So 10 divided by 65536 will give 1.526 millivolt. So this 1.526 millivolt is lesser than 2.1 millivolt. So when this is 16-bit board is selected, so it can detect a lower change in voltage, that means 1.526 millivolt. So this can easily detect 2.1 millivolt change in input voltage. So the correct answer for this is 16-bit board. So I am proceeding to the last question for today, and last question for today is question 35. So the question 35 says, which of the following statements is true regarding the use of clusters? So the first statement says the first object placed in a cluster is designated as element 0. This is okay, this is true. If you delete an element in a cluster, you must readjust the order of the elements manually. So this is also correct. Then the third, C, it says cluster elements are ordered based on their position in the cell. So this is a wrong statement. The ordering of clusters is not based on their position, but it is based on the basis on which elements are added first, second and third and so on. So it depends on the order in which the elements are added in the cluster, and that will decide the order of the cluster elements. It is not based on the position. So the option A and B are correct, and so this option D, both A and B are correct, will be the correct option. So I am finishing the session for today. I am sitting here for 2 minutes. If you have any queries, you can ask and I will try to resolve your queries. Okay, thank you very much. I hope you have enjoyed this session. Thank you.